Simplifying rational functions. A rational function is when you have an equation divided by another equation. That's what when they talk about rational functions. So that's what you have here. You have, the division of an equation and the equation divided by an equation. And we're kind of focused on, I know that word doesn't start out very nicely, but subtraction of them, okay? So we need to simplify this. So first thing I want to recognize is that we have 3 different terms. So we're going to call this term 1, term 2, and term 3. And how do I know what a term is? They're all separated by either a subtraction or addition sign. In our case, it's subtraction, but anytime you have a plus or a minus sign, that's what separates terms in an equation. Okay? Mm-hmm. Because this is subtraction, we essentially need to have common denominators to make this all 1. Now, when I take a look at this, I'm going to try to do some factoring.
Yeah, you want to factor some that out and simplify it.
So here, this is a term within itself. There is no addition or subtraction. This is essentially simplified.
2x times 2x.
Yes. Here we can do a little bit of factoring. We can do a common factor out.
X times x minus 1.
Yeah, exactly. Great. So I'm going to start rewriting it already then. So I'm going to put a little equal sign here on the left just to indicate that we're working with our question here. Mm-hmm. I leave the very first term intact, 3 over 4x squared. There isn't much we could do that. Technically there is, but we'll move along and then decide if we need to do anything to it. The numerator to the second term is 2, not much we can do there. But you're right, we can common factor here. So we look for a term that's divisible by both. And in this case, it's technically x. So x is the common term, okay? And when we divide whatever's left, so x squared divide x leaves us with x, so that sits inside the bracket. Subtract x divide x is just the value of 1, okay? And then we move on to our third term. Again, x is the numerator, not much we can do here. But we can do some division. There's a common term. You know what the common value is that we can divide from each of these 2?
2, I guess?
Yeah, we can pull 2 out. So we're going to common factor 2. So again, 2 comes outside of our set of brackets, and what goes inside is whatever the quotients are. Yes, exactly.
So
X minus 1.
Noticing a little pattern already.
Perfect.
Yeah.
So we have x minus 1 in both of these. That works very nicely for us. Technically, I can common factor this here. I'm going to split this up for us. Okay. I know I said there wasn't much we could do, but there is a little. It is going to help us now that I've looked at this. Mm-hmm. Each of these is a different term. So I'm going to break it into what's called prime factors. I don't know if you've ever talked about prime factors, but they sometimes show things and they call it a factor tree. A factor tree is when you just write the factors of a number until you can't break those numbers down anymore. So the 2 factors for 4 are 2 and 2. Factors of 2 are technically 2 and 1, so we consider that as basic as possible. So I'm actually going to break 4 into 2 and 2. Okay, so our numerator we're going to leave the same, it's 3. 4 becomes 2 times 2. And x squared, well, x squared we can break into factors too. X and x. Mm-hmm. So I'm going to write it as x and x. Now these would be considered the prime factors of this number here. Okay.
I think I wanted to do that the first time I took a stab at this question, but then I thought, no.
Would it be helpful? Yeah, sometimes you're writing and you're unsure if it's going to help at all. It's going to help us a little here, so we're going to take a look. We'll write the denominator again, x times x minus 1, and x over 2x minus 1. So, what do we need to do? We need to make sure that we have the exact same denominator on all of these. So, let's look at things that are common between them. I don't technically have a common factor between any, but there are common between a few. I'm going to use yellow to find commonalities between the first term and the second term. So there is an x and there is an x here. Okay? What does that mean? That means this is missing an x. So what am I going to do? I'm actually going to write it in. Now when we write it in, you got to write it toward, attach it to the bottom and to the top. Okay? So bottom and top. Great. So now we have an x, an x, and an x. That one's checked off. Okay? Between the first term and the last term, well, I have a 2. A 2 and a 2. What does that mean? That means a 2 is missing here, so I'm going to write the value of 2 in. And whatever you do to the bottom, we must do to the top. Great. We have a 2, a 2, and a 2. Those are taken care of. There's a commonality between the second and the third term, which is x minus 1 and x minus 1. What does that mean? Well, that means x minus 1 is missing here, so we're going to attach it. I'm kind of running out of room, but x minus 1 and x minus 1. There we go. That's all taken care of. X minus 1, x minus 1, x minus 1. What is left over? Well, I have a 2 and an x left over. I can technically just attach 2x and 2x to both of these, and then all our denominators are going to be the exact same. Okay, I'm going to just do it in the next line just so we have some space. So I'm not going to simplify anything yet, but we have 3x minus 1. Okay, give us a big denominator. We had 2x, x minus 1. Okay, subtract 2 times 2, big denominator again, x minus 1, 2. I'm going to write something else in there, and then subtract x. Now, when you get proficient with this, you're going to not want to do all of the steps I've done, but this is essentially breaking it completely down. Right. So like we stated before, things that are occurring in everything, there's a 2, there's a 2, and there's a 2, so that's checked off our list, and x, and x, and x, that's checked off the list. X minus 1, x minus 1, x minus 1's off the list, so what's left over? Well, we need to deal with this 2 and this x, so we're going to attach it to both of those, okay? So a 2 on both the top and the bottom, and an x on both the top and the bottom. I didn't give myself a lot of space on here, so I'm going to just attach it to the front. 2x and 2x. So I want you to notice something. Here I separated them as separate terms. Here I put them together. It's technically the exact same thing. Yeah. So now let's write the entire thing out and this kind of simplify. So we got 3x minus 1 above 2. And again, when you get good at this, you're going to be like, this step here is redundant. I don't need to do it. That's great. That means you understand it quite thoroughly. What do we got here? We have 2 times 2 times 2 times x over x times x minus 1. I gotta remember to write smaller. 2x. Subtract. Technically this was 2x, x. Lots of x's. All over. 2x, 2x minus 1 and x. Okay. Now, even though, if you notice, this is in a different order than this, and this is in a different order of this, there's a rule of multiplication called associative property. It doesn't matter what order you multiply stuff, you always get the same answer.
Yeah, come to the same thing. Yeah.
So what does that mean? We just need to multiply one of these, and then we can just replace the other two with the answer. So we're going to simplify the denominators first. The top is 3x minus 1. Okay, first I'm going to multiply out all my constants. So 2 times 2 is 4. X times x is x squared. So that is, I'm going to do it down here, 4x squared. And then technically, this is times x minus 1. So we have to use like a distributive property, okay? So I'll write it as a step here. So 4x squared times x minus 1. That means 4x squared's got to multiply by the first term and by the second term. Sometimes they call it like a rainbow, or attaching it to every term in there. I'm just going to put some quotation marks here to say that that's the same, because I don't want to write it all the way out. But essentially, we're just bringing down this term here, this term here.
Yeah. Now, at what point do we like cancel things out? Because like we have x minus 1
You're
on
right.
top and
In
bottom.
fact, you got a great point. Before I started doing that, that would actually make a lot more sense. Let's start canceling things out, because, oh, wait a second. Let me think about it for a second. You made me think about this. I know when you get to a point like this, you're like, oh, let's get rid of those. They're there, and you got 1, 2, 2s. That's nice, and x, and 2, x, 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 x. Get rid of all those things. But what does that do? It actually just takes us up to right where we started. Yeah, and that's not the goal right now. The goal is to get a common denominator. So once...
So don't start doing that too soon.
Yeah, once... Well, too soon, what do I mean by too soon? Too soon would be once we've solidified a denominator, then we can start, eliminating things, but you're going to notice that there's actually going to be nothing to eliminate after. We've actually... This process has simplified stuff. So let's finish our denominator here, and then we'll talk about the tops. So again, I'm just bringing those down. I don't want to rewrite them again. We want to multiply that distributive property here. So the numerator is still 3x minus 1. our denominator. 4x squared times x is 4x cubed. 4x squared times negative 1 is just negative 4x squared. Okay, there we go. So we have it now. That's our denominator. So what does that mean? That means that's the denominator for all three terms. 4x cubed minus 4x squared. 4x cubed minus 4x squared. It's the same for all of those. That's what our process did, made them the same. We'll bring down the other numerators. 2, 2x, and then we'll simplify them to 2x, and finally 2x. Okay. Now you might look at this and go, I can common factor here. I can take 4x squared out of x, out of each of these, and that leaves us with x minus 1. But again, we're just going back and forth, and it's probably not going to end up helpful at this point. Once we do some of it, actually no, it's not. We're going to continue with what we're doing here. So now that we have a common denominator, so the denominator is the same throughout, we're just going to write this as one large fraction. And that one large fraction is going to just be over our one common denominator, which is 4x cubed minus 4x squared. What's going to be on top? Well, it's the simplified numerator. So we're going to use distributive property. 3 times both of those, so 3 times x gives us 3x. And 3 times negative 1 is negative 3. Okay. I'm going to leave it as a set of brackets. This subtraction sign kind of bumps up to the numerator. This becomes 2 times 2 times 2. That's 4 times 2, which is 8. Yeah. So we get 8x. Okay. And subtraction sign again. This is 2. X is x cubed, so we get 2x cubed. Now, we take a look at this. These are subtractions. Well, technically, think of it like this. This is a negative 1 on the outside, and we've got to multiply it to both of these. So both of these terms are just going to be negative or a subtraction sign in front of these. And we're going to drop these brackets off here. If nothing's showing, you assume it's positive, which doesn't change any of the operations. So we have numerator 3x minus 3 minus 8x minus 2x cubed divided by 4x cubed minus 4x squared. Okay. What do we do with the numerator? We try to find like terms. So 3x.
8x, so negative 8x, so negative 5x.
Perfect, exactly.
Now, would we put the cube at the 2x cube sort of in the front?
Yeah, so
like, is that sort of
the common
convention?
practice? Yeah, the common convention or practice to it is the variable with the highest degree is the first term. There's nothing wrong with writing this way. Mathematically, you're 100% right. It's just a practice that people tend to do so it's easier for others to read in math.
Right.
Again, not wrong though in whatever order you're writing. But let's do that because that's probably what your teacher wants. So this negative follows the term. So think of it like it's negative 2x cubed. Okay. Like you said, the next one would be these two, and that would be negative 5x. You subtracted them. And the last term is the constant negative 3. Not quite a trinomial. There's technically an x squared missing in here. If there's just an x showing, technically think of it like it's to the power of 1. So we can't do any quadratic factoring. I don't know if they've taught you long division factoring. Unlikely, and I don't think it's going to help us much with what you're doing. I think this would be considered actually your simplified form. You'd be probably very happy with, with just this.
Yeah, he's more sticky on...
it might be sticky with the denominator. Well, I don't know if you remember before, we talked about where if we factor this out, it just becomes this again. I mean, you can write it this way. Again, there's really no difference here. And the factoring, in our case, is not going to help us. We're not going to be able to eliminate anything. It's a bit redundant. So what I'm going to do is I'm just going to say, or if you did factor the denominator, your simplified version would be that 4x squared. And that would be x minus 1. Again, now I knew this wouldn't help, but maybe you need to write it out to see. There's no term here.
Because it could sort of be factored further. You could sort of have like 2x times 2x times x minus 1.
Yeah, well,
kind
the
of.
point was essentially to combine them all into one, right? They said
Right.
to simplify this rational function. Essentially, can you make it one big fractional function? You could always argue here if they've told
right.
you not to.
It is, sorry.
The original?
It's saying simplify here.
Yeah.
Because sometimes they'll just give a block of questions at the top. It says, please factor completely.
And
Yeah.
here, the argument here, if your teacher ever say, if you left it here and they said, why didn't you put it back this way, you lose a mark. The question should be, what's the point of doing this? Because if it doesn't help me, if it doesn't simplify a question more, it's just extra work. It's not helping. So if you ever get to here and the last step was not factoring, you can make an argument in the future, but what's the point? Because if there's no point, mathematically, there's really no reason to do it. Math is supposed to be about efficiencies. There would be no reason to do something like that.
Yeah.